Investigate the force of gravity, and we're going to do it virtually because the force of gravity is so small that we can't possibly measure it with any equipment we can afford for a high school lab. So here's how the simulator works. You have two objects, M1 and M2. You can move these objects horizontally, so you can grab one of them and slide it. It makes this goofy little noise when it slides, so you can turn your volume down so it doesn't do that. The other things you can do is you can change the mass of the objects. So this changes the mass of object 1. You can also use the arrows, and this changes the mass of object 2. Okay? Lastly, you can move the ruler. So to get the distance between them correct, you can move the ruler so that the left-hand mass, and you always measure from the center of the masses. The left-hand center is exactly on 0, and then you can move the right-hand one. Okay, so whatever you're supposed to put the distance between them to, make sure it's exactly right. So in this case, that's 0, there's 3. This is 3.4 right there because each tick is 0.2 meters. Okay? All right, so once you know how to use the simulator, you can see the force that is exerted between them. The force on M2 due to M1 is extremely small, and you're going to have to type that into your spreadsheet. Now, it is a lot easier to use scientific notation than to drag along all those zeros and possibly get them wrong. So down here on the force values, you can click scientific notation, and then in your spreadsheet, you can just type 2.08 E negative 8. So that's how you would enter this force on your spreadsheet. So on your spreadsheet, you're going to enter the month you were born. This provides a little bit of randomization. So for example, if you were born in July, you would put in 7. So the values you get here that you're supposed to use for your lab, they depend on the number you put in there. So make sure you put in your birth month. Okay, so it says keep the distance between the centers to be 6.6 meters. So on your lab, you'll have to make sure the distance between the centers is whatever it tells you. So make sure you get it right. And so that would be right about there. Okay, so once you've done that, it tells you keep the left mass constant at some value. And then you are going to vary the right mass. And for each value of mass 2, the right mass, you're going to measure the force. So that one we just did, 2.08, you're going to type a capital E and then a negative 8. And it will put it in there in scientific notation. Okay? That's a lot. You can also type 0.0000, all those zeros, but it's easy to get them wrong. All right, once you do that, you're going to find a math model and put the conclusion on the math model. And then don't forget down here, there's a part B. It'll tell you what to do, so follow the directions carefully. One last thing to note, when you find your straight line, put just your slope in this box, and it will turn green if you're right. So that's a way you can check yourself and get a little confidence that you're on the right track, okay? So just the slope. Don't put y equals anything, just the slope of your line in that box. It'll turn green if you're right. Okay? All right, good luck.